I was going to go, oh, you know what? Before you can erase, but I just wanted you to get the hang of it. I do want to say one thing about the problems that we just did. I just want to give you a tricky one. Could you write this down somewhere on your arm, on your whiteboard? I don't care where you do it. Can you do this problem real quick? Just do this bad boy real quick for me. Sorry. That's a 5. It's not an S. Can you plug in? You can do it on your paper, you can do it on your whiteboard, do it on your arm, do it on your neighbor's leg. I don't care. Just do this one. This is one of those things that that we catch kids on all the time. I catch myself on this one all the time. So you may end up getting this problem wrong because you did something really goofy in the beginning that is very, very, very common, 1,000,000% common, and I'm going to show you what it is in a hot second. And I'm going to do the I'm getting -64. Yeah? Did you get it? Yeah. So if you didn't get -64, I'm going to tell you why. Don't feel bad. I'm trusting it. It's -64, and let me tell you why, because I know exactly the mistake you made. Here's what. You're plugging in, and here's what you did. You went negative, and then you went -5 squared, right? You did this little dude right here, and then you went 7 with the -5, right? And then you went -4, and you might have even done this guy like this. That would make me happy. So here's what you did. You went negative and made it a positive, and then you squared it. So you got 25. And you forgot our friend PEMDAS, order of operations, meaning you got to square this bad boy first, right? So what you got to do is make that 25 and then slam that negative on. So when you have a negative outside of a variable that is squared, you square it first and you attach the negative, because I want you to think of this as like a little -1. So you square him first and then you do the little -1 guy. It's very common, and I just want to throw that in there just for the fun of it. So here's the deal. I'm going to tell you a goofy story like you care, but this is you know what? This is why I teach, because I get to decide by goofy stories. So my last name is Tarantino. Clearly, I am one of the whitest people you know, that you could read by the light of my skin. Tarantino, though, is full-on Sicilian. It is a full-on Sicilian name. My husband is 100% Sicilian. Both of his parents spoke Italian. So he is 100% Sicilian. My children, if you ask them what they are, they would say, we're half Italian and half regular. Thank you. Regular. That's me. That's what I got. So the reason I'm telling you this, not that it matters, both my husband and I, oddly enough, were raised as Catholic people, but we don't practice religion. But my husband, full-on Italian, went to Catholic schools, grew up in the city, thinks he knows stuff, right? And we were in the hotel taking Thomas to Cal Poly last weekend, and he goes, there's a Bible in every hotel room. And we're joking around, and he goes, you know what? In Catholic school, I believe I read the whole Bible. And I said, you are a big fat hairy liar. Because he's Sicilian, he's super hairy. He's not fat though. You are a big fat hairy liar, you haven't. And he goes, I have. I know I have. And I said, really? And I said, so if I open the Bible anywhere and I read a passage, you could tell me what it means. And he goes, I could. And I said, you are so full of crap, right? And of course, I open the Bible up and I just pick a random passage. And I don't know if you've ever read an actual religious text, the Quran, the Torah, the Bible. They're very complex. They're not easy to understand. So I read this passage and I'm like, dude, what does it mean? And he goes, it means God stuff. And I said, you're an idiot. I married an idiot, right? So the point of that story, besides my husband being an idiot, and he's not totally idiot, but a little bit. The point of that story is this. I believe that math textbooks are a lot like religious textbooks, meaning they're very hard to understand. If you've ever been absent and the teacher says, just read the book, you thought, it's written in another language. I don't even understand what it means, right? And then what happens, here's the deal. if a teacher is teaching straight from the textbook, then a lot of times the stuff's not super understandable either. Because I believe my job is to help you interpret it. Like I'm supposed to take the confusing stuff and make it easier. I will refer to it this year as the Mrs. Tarantino way. Often it will have slightly weird things, like you're like, that's kind of weird, but it makes sense. All I'm doing is I'm simplifying situations that are maybe pretty complex. Do I actually know the real thing? Yes. Will I often say, here's the real definition, but here's the Mrs. Tarantino way to look at it? Yes, but I don't want you to walk out of here and feel like, she doesn't actually know math. I do, but my job is to simplify it for you. The reason I'm telling you all this is because we're going to start with the basic deal here, like why do we do pre-calculus? And why do we do actually any algebra? Do you know this is really just algebra? It's just advanced algebra. We call it that, I don't know why. We have beginning algebra, we have intermediate algebra, and we have advanced algebra. And we're doing advanced algebra, which is pretty much the same stuff we've been doing, just more and more complex. But the reason we're doing this is for one reason. As humans, we need things to be predictable, right? If you get a cut on your leg and it gets infected and you go to the doctor and the doctor says, yeah, I got something for that. It may cure it or it could actually poison you. Are you good to go? You're going to be like, I think I'm going to be fine. No, thank you. I don't need your poison stuff. You need it to be predictable. You call your mom and you want her to, bring you some Chipotle. You better make certain that phone number, that mom's answering, right? So you need things to be predictable. So in pre-calculus, we study functions. And the reason we study functions is because functions are mathematically predictable. So we're going to talk about if something I don't know how to spell that. There it is. Predictable. We're going to be looking at stuff and deciding, is this a function or not? And you learned the official math way, which said something like this. Each domain maps to a unique range. And you thought, I don't know what that actually means. And what I'm telling you it means is this. Is it predictable? So let's talk about the vending machine. So I've got this cool vending machine and I come in and I push button number 1 and out comes delicious ice cold Dr. Pepper and I'm happy. Yay. And the next day I need a little pick me up. And so I go to this vending machine and I push button number 1, out comes delicious Dr. Pepper. I'm loving my life pretty much. And the third day I push button number 1 and out comes a bag of human vomit, right? Guess what? I didn't want human vomit. I wanted Dr. Pepper. I am not happy with this because guess what? It's not predictable. I'm not going back to that thing again. Who was the weird worker who put that in? I don't want to know about it. I don't want to ever get another bag. One year, let's see if it's over here. Someone made me a bag of human vomit. I can't, there it is. Look, vending machine human vomit. And if you hold it, it's got weight. So, and if you look at it, it actually kind of looks like vomit. But so do I want to get that in the vending machine? I don't want to get that in the vending machine. I want Dr. Pepper. That would be an example of not a function, right? It's not a function if it's not predictable. So right now, I am going to ask you to talk to your neighbors. And I am going to show you some stuff. And I would like you to decide, is this a function, yes or no? So we got button number 2 and we got button number 3. And I walk up and I push button number 1 and I get delicious Dr. Pepper. Every time. Yay. My daughter comes up and she pushes button number 2 and she gets a Coke because she's a Coke girly. Yay. And my husband comes up and he picks the worst soda of all. He pushes button number 3 and he gets root beer. You know why root beer is bad? Because you think it's something else and it's not. And then you're like, because it's root beer. And he pushes root beer. So here's my question. That happens every day. There's no human vomit. There's no tricks. Is that a function? Talk to your neighbors. Decide if that's a function or not. Talk to each other. What do you think? Yeah, it's a function. It's predictable. Those buttons match with those things each and every time. It's predictable. We're feeling pretty good about ourselves. How about this? What if I do this instead? I go and I push button number 1 and I get delicious Dr. Pepper. I push button number 2 and I get delicious Dr. Pepper, and I push button number 3 and I get delicious Dr. Pepper. Please talk with each other. Is that a function? What do we think? Is that a function? No, yes, actually it is. Boring. It's a boring function, but a function nonetheless, right? Because it's predictable. It's just filled with things, right? When you take a multiple choice test and you know you get all freaked out because you get a bunch of B's in a row, like number 3 is B, number 4 is B, and number 5 is B, number 6 is B, and you're like, I did something wrong. No, it's weird, right? But it's predictable. Number 2 is B, number 3 is B, number 4 is B. That's okay. So sometimes you can use the ranges more than once. That's okay, right? So let's look at one more of these and decide. How about this? What if I go 1 is Dr. Pepper and 1 is Coke and 1 is 7-Up? Function, not a function. Not a function, right? Because I don't want these other things. I'm pushing button 1, right? So that's where it gets tricky, because you all think like, can I use the X's more? Can I use the Y's more? And I want you to try to train yourself to think to yourself instead, is it predictable? If I plug in this single number, do I get the same answer every time, right? Okay, so that said, let's talk about some vocab, right? Just a little bit of vocabulary. We're going to be writing functions in one of 2 ways. If I am being good, and I rarely am, I should write it and print it that way. I am super lazy, and often I will switch it out and write it this way, right? They are fairly interchangeable, right? But this is really the right way to do it. The X, the thing that goes into your function, right? That's what's going in. He is called the input. He is also, we refer to a bunch of X's as the domain. And he is what we call the independent variable. And here's why. You get to pick what freaking button you want to push, right? I'm not holding a gun to your head and say push button 3. You push what you want to push. That's why it's independent. The stuff that comes out, the answer, we refer to sometimes as Y, or we refer to it as the f of X. It is the output. A bunch of them are, oh, I like this output. A bunch of them are called the range, right? What comes out of our little machine. And it is the dependent variable. And here's why. It depended on what button you pushed, right? Now, what kids often ask me is, what the hell does this guy mean? What's his job? Here's what's goofy. So I'm going to tell you another true story. The 70s and 80s were much better days. And here's why. This is God's honest truth. When you went to my high school, if you went to the vending machine, because we had vending machines, by the cafeteria, it was filled with soda. It was so good. If you went to the vending machine by the library, it was filled with candy. That's how clubs made money, is that they put stuff in the vending machine. Like full-on candy, M&Ms, whatever. And we even had a vending machine by the locker rooms. You know what we had? Slushies. I am not lying. Little plastic cup came out and you got a slushie. It was, and not like a healthy slushie, like we're talking syrup, like water. It was a little slice of awesome, right? So here's what. If you said to someone, oh, I'm going to meet you at the vending machine, you couldn't just say, meet me at the vending machine. You had to say locker room vending machine, the library vending machine, the cafeteria vending machine. So you know what that F is? That's the name of this function, right? He's F function. We might have G function, but that letter, that's just his name. That's the Fred function. Talk to me.
Please keep teaching, but I need everybody to stay out there, John Vex.
I already caught someone with a Duke one. I know. Can I?
Leave it on your thing. This turns you need to keep teaching.
Okay.
Hold on. Leave it there.
So I'm going to keep going when it's out. So here is the math way to know if something is a function. Do you need to write this down? No, because you've already learned it. But it's the scary way. It is that each domain maps to a unique range. Each domain maps to a unique range. That doesn't make any sense to you. Here's what makes sense to you. The Mrs. Tarantino way is it predictable? And there are going to be times when you're going to look at me and say, I can't tell if this is a function or not. And I'm saying, is it predictable? Is it predictable? Right? Okay, so here we're going to go. We're going to talk to each other for a minute. I got 3 little guys up here. I got A. I got B. I got C. Please turn and talk to your neighbors. Tell which ones, 2 of them are functions, 1 is not. Decide as a group which ones are, which ones aren't, and why. Talk now. Go now. None of them isn't.
It has 3 different outcomes. So it's not
2 are 1 thing.
I was just saying C.
Oh, what if you have the same
Okay, so here's what we're talking here. If I plug in 5 for these, I get 3. Every time I plug in 5, I get 3. Every time I plug in 8, I get 3. That's okay. Every time I plug in 23, I get 3. That's 4. But look at C. Today I plug in 5, I get 3. Tomorrow I plug in 5, what do I get? I get 8. Does that make sense? So here's what you want to do. What's the best way of doing this? You can use the first guy. So look at this. Let me show you. Yeah. So let me move this guy. I plug in 5, I get a 3. The next day I plug in 5, I get an 8. I don't know what the hell's happening here. Not predictable. So C, not a function. Are we good on that? Yeah? Okay. So then when you got to Algebra 2 and Algebra 2 trig, you learned a thing called the vertical line test. But you didn't know what the hell it meant. You just drew a line and you said if I cross at 2 points, it's not a function, right? But now you realize it's about predictability. If I plug in the number 1, I get 1 answer only. If I plug in the answer 2, I get 1 answer only. If I plug in 3, I get 1 answer. If I plug in 4, I get 1 answer. But watch what happens on this dude. I plug in the number 1. Do I get this answer? Is that the right answer? Or is that the right answer? I don't know. And the minute I don't know, not a function. Does that make sense? That's that vertical line test. If you hit it twice, or 3 times or 4 times, it's not predictable. So here we go again, my sweet, sweet potatoes. Take a look at A and B. Decide with your table group. 1 is a function, 1 is not. This should be a pretty easy one. Turn and talk. A and B, which one's the function, which one is not a function? Are we good? Yeah, nice and easy? Okay, I've led you down the primrose path to easiness. We're gonna go big time now. Because you're like, Miss T, I'm so smart. You're making this is too easy for me. So let's talk. Let's get into it. Let's look at this guy. The domain is a cell phone number. And the range is a specific cell phone. Is that a function? Yes or no? Turn and talk. Think about actually dialing the number and what you predict should happen, right? Think in real life. You're calling your mom. What will happen when you dial your mom's cell phone number? What do we think? Is that a function, yes or no? Let me ask you this. You dial that number because you want Chipotle, you want to pick up Chipotle, and some weird guy from Yugoslavia answers. Either your mom's having an affair with some guy from Yugoslavia, or, which could happen, that's not right, that's not us. someone's stolen her phone, but her phone better ring when you dial that number. Only one phone. If someone calls you and 3 people answer, that would be bad. Each cell phone number goes to a specific cell phone. But now we're going to get to really weird. You ready? Here we go. Here is my address. 4595 Deer Creek. If you live in the crossings, you live near me. I live in Turtle Creek. Okay, so here's what. You're looking for me. You're looking for me. You've decided you're pretty mad about pre-calc and you want to have a word with me. So you go there and knock on the door. Am I answering the door? Talk? Is it a function? Is it? Is it? Think about what you know about me. Somebody else. What do you think? Is this a function? I think it's no. I think I'm nodding like saying that's not a function. And I agree, because guess what? My husband might answer the door. My son could answer the door. I might move tomorrow and someone else moves in, right? There are lots of people who could be legitimately living at 4595 District Road, right? My son and my daughter could be there. So will you obviously get me? No, there are lots of people who are attached to that address, not just me. Let me try one more. What day is your birthday?
March 30th.
March 30th. So March 30th, that date, that birthday, and David, is that a function? If you decide that you are going to give a birthday present to anyone whose birthday is on March 30th, will David get all of the presents? Why won't he? Other people have that birthday too, right? Because if I say March 30th, I'm gonna give presents to the March 30th, there could be someone else, right? Is it predictable? Is it predictable? We got one last thing to do. I played Sabrina Carpenter dinner because we were going to talk about domain and range, but I am running out of time today. So we're going to just dive to the last part. This is easy. You've done this before. This is whiteboard stuff. You might not even have to write any notes down. Just a quick reminder. When we want to evaluate a function, when I say evaluate it, I'm looking for an answer. Nice, easy, light work. So if I say f of 7, and I want you to do it, what this says is go to function Fred, and everywhere you see an X, pop out the X, put in X's new name, which is 7. Really, you don't even have to write this down. Whisper to your neighbor, what happened? What is f of 7? Whisper right now, because you shouldn't even have to do any math. Like, this should be super easy for you. 26. Yeah, 26. Okay. Now I'm going to get a little tricky for you. What if I did this? Here we go. F of X equals, I'm going to make it a nice thing here. I'm trying to think of something that works out pretty nicely. 35. F of X is 35. What's happening there? Here's what. This is not the same thing. This is going backwards. What I'm giving you is the answer to the problem, and you need to now go backwards. In other words, I'm getting rid of Fred's name, f of X, and I'm putting the 35 right here. Does that make sense? So you got to be careful here in pre-calc, because sometimes I give it this way, and you're going forward, and sometimes the problem will look like this, and you're going backwards. And if you got 10 for that, you are a professional. You are awesome. Okay, I'm stopping here. We got about 7, 8 minutes to work on your practice tonight. I'm going to give it to you right now. And I'm cutting. Stop.